Hi everybody, in this video we're going to learn how to create one of my favorite animation effects, and that is known as the Starfield effect. And this effect has many names. You might also know it as the hyperdrive or warp speed effect, and the general idea is this. It creates the illusion of stars just flying past us really quickly as we are moving through space. Now, before we get to the coding and how this animation is built, let's take a step back and just talk at a high level about how we're going to approach solving this particular problem. The setup is as follows. Imagine we're looking out from the front of a cockpit of a spaceship as it is zipping quickly through space. Here's an example of a cockpit from Star Wars, and you can imagine as this vehicle is flying through space very quickly, all the objects around it, in this case primarily stars, are just flying right past us. And so the thing to note is that just like everyday physics, as we're driving or looking at something far away, objects that are further away fly past us slowly. Objects that are closer to us are going to be moving past us very quickly as well. And all of this is happening while we're at the center of all the movement and we're flying through space. And to go one level deeper, the point that we're looking out through is a focal point, outlined as this little circle in the middle of our screen. And it's how the stars move past this focal point isn't random. And this is really what helps create the illusion of the Starfield effect. There's a very specific path that they follow, and it's based on where they're initially positioned and where a focal point happens to be. And let me draw a few more lines to illustrate that. We can determine that path by drawing a virtual straight line from the focal point and going through each star, as we have seen right here. And you can see there 1, 2, 3, there are 5 stars, and you can see that each of the stars now has a line going through it, where the starting of the point of the line is our focal point, and it goes right to the center of the star in whatever angle it is currently positioned in. And if we had to simplify our Starfield effect greatly, it is nothing more than each star moving past us on this virtual straight line. Now there's a bit more going on as well, but that's really the elevator pitch of how this animation works. There are 3 things that we also do as part of this animation that gives it more of that realistic effect. One is the stars, they will grow as they become more visible and they start flying past us. Just like in real life, things are further away or small. As they get closer, they get much larger. The speed at which each star moves is going to vary. Some stars will move very quickly, some will move very slowly, which creates this nice illusion where just because an object is large doesn't mean it's going to be working very slow. It could be that it's an object very close by to us, which means it's moving really quickly. And also an object moving very slowly in a distance doesn't mean that it's just a really large object. It could just be that it's literally moving very slowly because it's an asteroid, has some other effect on it. And lastly, once a star has disappeared past our view, we reset its initial position, size, and speed with the brand new values and have it fly past us again. One of the key parts of this effect is we saw there were many stars flying past us. We're not actually creating an infinite number of stars, we're recycling stars. So once a star goes past our viewport, we go back and change all of its values to put it back in a new costume and have it fly back to us directly again. There are pros and cons to the approach, but it definitely just helps make our coding and our life of managing the life cycle of various objects much simpler. Now, what we're going to do is go ahead and start going to your favorite code editor, start writing some code. If you want to follow along with the code snippets and what I'm adding, easiest place to go to is to see the text-based version of this video. I wrote an article on curve.com about creating an animated 3D Starfield effect in JavaScript. Link in the description below, but go there and then you can follow along with the code snippets as I'm writing it, and you'll be able to see how everything is coming to life. Alright, for the coding part of this video, use whatever code editor you want. I'm not picky about it. As long as you can write some HTML and be able to preview it in your browser, you're in a good spot. And so what I have here is a blank HTML document. Let me go and close my file and folder view and zoom in a bit so you can see things much more clearly. And I'm going to start creating the application from scratch. And in between me writing my HTML, CSS, and JavaScript, I'll pause momentarily to explain what the code is doing if it's something convoluted. But the idea really is to see it being built gradually, just like you would build it if you were to do it yourself. So I'm going to minimize copying and pasting and just giant leaps of capabilities. And you'll see me going and backtracking in some cases as capabilities are being created. All right, so let's go ahead and first create the beginning of the document, which is an HTML document. And so I added some boilerplate code here. If you are using VS Code, just use the exclamation mark and hit enter to get all this comment going. So I'm going to change the title of this to be Starfield effect. And let me just make sure that when I refresh the page, everything's still good. Okay, nothing is changing here. Nothing is happening that's going to require a major preview to show something new here. All right, so the first thing I want to do is our effect is going to be created on a canvas. So it's going to be a canvas-based animation. And let me first make this a canvas element. So canvas ID equals, and let's go ahead and give it the value of outer space and get a height value of 500 and a width value of 500 as well. And this will go and close our canvas element. And of course, a canvas by itself doesn't really do much. So let's first style it so that we can at least see it before we start adding our capabilities to it as well. So style, hashtag outer space. Let's give it a border, 1 pixel solid, and make it a very dark gray. And also border radius. We'll give it a 10 pixel border, and then we'll get a filter of a drop shadow just so we can see it more nicely on this white background. 0 pixels, yep, no offset, 10 pixel, and a dark gray again. So let's go ahead and refresh the page here, and you can now see we have like the outline of our, in this case, our canvas showing up. Let me zoom out just a little bit so it doesn't seem too large and overbearing here. Let me also give like a slight padding to our, or margin to our body so it doesn't look like it's too flush against the edges of the previous surface itself. All right, so here we have our canvas. Let's make the border just like, let's make it 3 pixels so it's even more obvious in case you're watching on a phone and you don't want to zoom in too much. Okay, so here's where our Starfield effect will eventually appear, and you can see the drop shadow subtly showing in here, depending on the compression, of course, that YouTube is using for this. So the first thing we want to do is just get our canvas to get initialized, have some basic scaffolding in JavaScript going so that we can start writing some code against it. And so I'm going to go ahead and add our script element, our friendly script element where all of our JavaScript will ultimately live. So the first thing I want to do is just get a reference to our DOM element. So let outer space equals document.query selector, and it'll be hashtag outer space. And if everything works well, that means that the DOM element, the canvas ID here, will be referenced by this element right here. Main context equals outer space dot get context, and it's 2D. This ensures that all of the operations we're performing are going to be the two-dimensional operations that in this case are going to be provided by our context object. Other versions include 3D and WebGL and all these things, which we are not going to be getting into today. So let me create some variables. Canvas width equals outer space dot width. And let me just copy this just so to save a few characters and make this canvas height equals outer space dot height. And this allows us to have a reference to the actual 500 by 500 pixel dimensions of our particular image. And next, let me just create a draw function. So I'm going to call this draw. And inside of it, I'm going to do main context dot clear rect. I'm going to clear the entire screen, 0, 0, and canvas width and canvas height is our variables. And main context fill style equals 0, 0, 0. In this case, actually, I want to make it 1, 1, 1, not fully black, just very close to black. And then we want to clear it out again and say it's full width and height. In this case, my AI assistant is coming in and like helping me out, but if I didn't have it, I'll just be typing these same values in. Let me just refresh this page to make sure that everything is going well. And oh, that's right, I'm not actually calling the draw function anywhere. Now you'll see that our canvas is now being drawn, and you can see the dark gray background appearing. This is progress. This at least shows that our code is working, there are no major errors, and nothing glaring is going on. And so now it's time to create our stars. This is going to be a multiple path effect here, where I'm going to start with one approach and I'm going to gradually modify it as I learn more about how this effect should work. So the first thing is I want each star to be an object. So I'm going to create a class called star. And inside of it, I'm going to have a constructor. And this constructor value is going to initialize some basic, instance variables that we need for it. So this.x equals, in this case, get random. Oh, okay. So I want to make sure that x and y position are randomly positioned on screen, so it's not going to be like, I'm not going to specify each of the hundreds or thousands of stars in its own location. So I'm going to create a helper function. So, ignore this for a moment. I'm going to stop this right in the middle right there. And I'm going to do function get random int min value, max value. And this is a helper function because I'm going to be using this quite a bit. Return math.floor, and it's going to be math.random times max minus min plus 1 and plus the, actually, plus min. Okay, this looks to be, yep, this is correct. And so now I'm going to type in get random int, and it's going to be 0 to canvas width. And then this dot y is going to be get random int 0 to canvas height. And this ensures that our initial variables will be able to, a star will be put in from the left edge of our screen or the right end of the screen, or the top edge of the screen or the bottom edge of the screen somewhere. And while I'm also at it, let me go and do a radius value equals 1 plus math.random times 10. This gives each star its own unique size, and then pass the context argument as well. This context equals main context. So this is our initialization, or at least the class for the star with the constructor. So each time we create a star object, these values will be somehow either inherited or calculated and provided. And also I want to have a draw star method. I want each star to be responsible for its own drawing. So I'm going to do main context dot begin path. I'm going to be drawing a circle essentially for a star. It can be anything you want it to be, but in this case, star seems appropriate. A circle seems appropriate because it's simple enough. And so the way to do this, main context dot arc, it takes a handful of arguments, which is really, you can see, it takes the x and y position, radius, and start angle. So I'm going to do this dot x, which we've already specified as part of a constructor. So, and then this dot y will be its horizontal and vertical positions. Its radius is going to be specified by this dot radius, and it's going to go a full circle. So it's going to start at 0 and then go all the way to math.pi times 2. And the counterclockwise or not counterclockwise, not too worried about that. I'm just going to false right now. If we had overlapping elements and you had like various things that are going into other elements, this value might determine how the drawing and the coloring of these elements will take place. Nothing to worry about right now. So I might be giving you more detail than you might need to for this one. So I'm going to do close path. So once we draw it, I'm just going to close this path, and then main context dot fill style, give it a dark color, not dark color, a light color, make it pure white, and then main context dot fill. All right, so this essentially tells me that I know when this draw star method is called, we're going to start a path, draw our circle, and give it a white background or fill color as a part of it. Okay, so once we've done this, if I refresh this page, again, nothing's gonna happen, which is actually by design because our star doesn't have anything going for it. It's just really just defined in code. There really isn't a whole lot that we're doing extra beyond it. So now let's go and actually start using our star object to populate our field with stars. So I'm going to do let number of stars is a variable I'm going to create, and let's make it 500. Let's have 500 stars. We'll increase it up later just to see how it looks, but that's good for now. And then I'm going to create a variable called stars, which is an array of, it's an empty array, and it'll ultimately store all of our star objects. And now let's do a setup method. So I have draw right here. I'm going to first go and do function setup, and let's do a loop for let I equals 0, I is the number of stars, I plus plus. I'm going to do let star equals new star, and oh yeah, this is actually not bad. I'm just basically initializing it and pushing a new star object as part of it, and I'll do setup right here. Okay, so let's refresh this page. Okay, so far no major errors, everything seems to be going fine. You're like, why is the star not showing up? Well, I'm only setting it up right now. I'm not actually drawing any of the stars just yet. This is just the precursor to stars being drawn, where we initialize a new star object, and it loops all the way up until the number, in this case of 500, which is our number of stars that we specified we will need. And now it's time to actually draw the stars. So I'm going to go to our draw method, our main global draw method. We have two draw methods. Well, it's actually called draw star, so not quite the same. And I'm going to do for let I equals 0, I equals less than stars dot length. It's the number of star objects we created here. And let's do I plus plus. And it says stars of I dot draw star. And that's actually, I'm going to keep it a little clearer. I'm going to let star equals stars bracket I, and then I'm going to then do star dot draw star. Sometimes the autocomplete can be pretty eager in what it's doing. So let me refresh the page now. And notice as I'm refreshing, you can now see splatters of white, almost like a Dalmatian, doesn't it? But you can see like the white color, the stars are now appearing. Each time you refresh, you see it differently because each star has a random position and a random size, thanks to our this.x initialization, y, and also this radius, where each of them are using a random value to specify how this is actually going. And I may be wondering, why am I not using get random int for specifying this random value? You're right, I probably should. So let me just go back here and make it from 1 to 10. Might as well use a helper function. Why does it exist, right? And you can see this right here. Now, this is a good spot to be in because at least we have our initial starting point for the visuals that will make up the stars appearing. Now, what we don't see, of course, is an animation. They're all statically sitting there. And this requires us to kind of do some more scaffolding to make the animation work properly. And we're going to jump back and forth in a few cases to kind of highlight some of the visuals that need to be thought about from our focal point explanation we saw earlier and how it maps to the code that we're currently seeing. So first, I'm going to go ahead and let's make this animation. Let's just have it move a little bit. And so the first thing is I'm going to create a counter variable. And this counter variable is going to be crucial because it's going to play the important role of keeping track of where each star is relative to us and our focal point and where the edge of this screen is. So it'll play an important role in essentially determining when a star is born, when it disappears, and when we reuse it again and reset its properties for it to appear one more time. So I'm going to start the counter value with, in this case, a large number, in this case, canvas width. We'll talk about this maybe in a future video on why we're doing it this way, but it can be canvas width or height, whichever is the maximum of your current dimension of your star field. In this case, I have a square, 500 pixels by 500 pixels. So canvas width is fine. I can use canvas height if I want to as well. Okay, so this draw star is great. And so each time draw star is called, I want to decrease the value of counter by 1. So it's going to be whatever, in this case 500, and we decrease by 1 slowly as we're going on. And now what I'm going to do is actually have the counter variable be used as the be all end all of how our stars are going to be moving. So I'm going to create two variables. One is the ratio variable to map the position of our star to the boundaries of our screen, and then actually get the value of our star itself in x and y coordinates. So let x ratio equals this dot x divided by this dot counter. Similarly, let y ratio equals this dot y divided by this dot counter. Okay, great. And so now we're going to use a remap function, and I'll talk about, have a link to remap tutorial below on what it does, but it takes a value from one range and moves it and remaps it to another range. So if you're going from like 0 to 1, but the output needs to be from 0 to 100, anywhere whatever value for 0 to 1 you have, it'll be scaled appropriately for its output, which is an important part here. That's part of how this is going to work. So what I'm going to do is I'm going to add the remap function as another helper function right here. So function remap value initial start, initial stop, output start, output stop, and that's going to be the initial part of it. And this one I am going to copy some of the code here. Most I'm going to walk through what it exactly does, so you'll get some time to copy it yourself. And let me format this properly. So what I'm creating is the remap function takes 1, 2, 3, 4, 5 arguments, and I'm basically just making sure it is casted as a number. So value I start, I stop, O start, O stop. Wow, tongue twister here. Are basically ensure that we are passing numbers, not strings. And then we perform the mapping calculation, which is this equation that we see here. Again, I'll have a link to a tutorial below that talks about how this works, but essentially, we return the O start value, you add it to in this case, the difference between O stop and O start multiplied by the ratio of the value minus the I start value divided by I stop minus I start. I know I basically just blurted out random variables and described like the mathematical equation, just literally shows up on screen. The article I linked to gets in more detail, but this is an important job of mapping from one value range to another. And so now that we have this, I'm going to go back and add two more variables. So in this case, that is our star x value. Star x equals remap x ratio, and remap it from 0 to 1 to 0 to canvas width. So whatever the percentage we get of dividing this by our counter value, I actually want it to map not from like 0 to 1, but in terms of the full dimensions of the screen that we're dealing with. So similarly, I'm going to create my star y variable. I'm just going to copy and paste my star x value, replace x ratio with y ratio, and replace canvas width with canvas height. Okay. And let's see, we have this. Let me refresh the page. Nothing's happening, which is exactly as I'd expect. And now I'm going to go and modify our arc function. So instead of saying this.x, I actually want it to be star x and star y, because this is going to be the one that's going to be changing as we are constantly moving how this works. And the last step is we need our animation loop. And so we have draw, and in this case, oh, the request animation draw somehow automatically made it when I was doing this earlier. I'm not sure, so imagine it's not, normally wouldn't be there, but now it is. The request animation frame, draw, and it's now available. So if I refresh my screen, you'll see basically the star moving out. You can see that we're zooming in, the stars are moving, and things look interesting, right? This is not exactly the effect that we want, because right now what it looks like is our focal point is at the very top left corner of our screen, which means that everything you're seeing is moving relative to that, and that's why you're seeing the stars moving bottom and to the right. Well, there's a fairly simple fix for this. We just make sure our starting point and our focal point are appropriately adjusted. And so the way I'm going to do this is by, first of all, we want to talk about, let me show you what exactly is going on. And for this one, I can bring the tutorial back into the screen. Give me 1 second here. It'll help simplify what's going on. Okay, hope you can all see this. So what we're seeing right now is literally this example where the focal point's in the top left and all of our stars are moving bottom, from the top to the bottom right. And so what we really want to do though is more focal point in the middle, so everything is moving appropriately. And what this means is we shift our entire drawing by half of canvas width and half of canvas height to shift the top left corner to be at the center of our screen. And as of course, because we're working on a canvas, how we logically explain what needs to be done and what we write in code is going to be a little bit disconnected, and I'll explain where some of that comes from. And so the first thing we do is let me declare a variable, or two variables actually. Let's center x equal canvas width times 0.5. So you're getting the center point from our horizontal position. And similarly, let's center y equals canvas height times 0.5. And in my constructor, I'm going to make another modification. The value of this.x is no longer going to be getRandomInt 0 to canvas width. It will essentially be minus center x to positive center x, which essentially means that we have shifted our entire drawing over to account for our entire focal point shifting. And so similarly, it will be minus center y and center y here. Now you're probably wondering, wait, let's imagine that we are dealing with, let's say, a value of 500 pixels. So center x would be half that, which would be 250, and center y would be half that of 250. If I'm drawing from a center x value of minus 250 and 250, I would be drawing kind of off screen. I'd be like where my mouse cursor is right here, right? That seems pretty odd. And so we're shifting pretty much the entirety of the square over and up by like 250 pixels, which is not quite what we want, but I agree. And we're going to account for that as part of shifting how we draw the actual values themselves. So I'm going to go back in this case to our draw function where we have our code right here, and I'm going to do a translate. So main context translate center x, center y. So after a background has been fully drawn, before our stars get drawn, I'm shifting our entire virtual canvas over by 250 pixels on horizontally and vertically, which means we're no longer shifting in this direction. We draw our circle, and then we reset everything back to its earlier position. So minus center x, minus center y. This is probably the most tricky part of this entire activity, believe it or not, because of just how the translation on the canvas works. The way to think about it, imagine you have a piece of paper and you're drawing something and you have multiple machines that are drawing on you. In this case, as the paper is being drawn on, after the first drawing instructions happen, which is you draw the whole paper in black, you then take the paper physically, move it over so the next machine can draw it using its new coordinates, and then after it's done, you move the paper back to its original position, so the next time you need to draw the full background black again, you're not having to deal with like this weird translated version of paper. It's all back. So in many ways, we're optimizing for the quirks of the canvas itself. So let's go ahead and refresh the page right now. And now you'll see that all of our stars are zooming in properly. It's not a case where like all zooming to the bottom to the right, they're zooming in like this. And there's another side quirk here now, like it zooms all the way in, but now it zooms all the way out as well. Like what's going on here? Well, this is part of what makes this fun, because now we get to finish off some of the other parts of our code that we left unfinished to account for some of these things. And so what we want to do is first loop the zoom effect so it doesn't zoom out like this. And the reason why it's doing it today is because our counter is unbounded. It just decreases by 1 forever. And then once it gets below 1, we don't reset it. We just keep having our animation run. So which is why it's going backwards, because the ratio on all these values now are going in the wrong direction. So simple change here. So if this dot counter is less than 1, which means it's no longer going to be, in this case, we're going to say less than that. We're going to reset some of these values. So this dot counter equals canvas width. We don't want it to go below that anymore. And this dot x equals get random int, and it'll be minus center x. And this dot y equals get random int again, minus center y and center y. All right. So let's see what happens now. Well, actually, you might not see a whole lot, but I think what we might see is that all of our stars zoom out. You can see they're flying past us. And then our entire animation resets again. Notice that, it's no longer zooming out awkwardly. It's just awkwardly putting you to a new galaxy where the stars are already there, or you kind of fell asleep and just suddenly woke up. Okay, so, we're making progress here. And so now what we want to do though, right, is there are 3 things we want to do. We want to make, to repeat what we talked about in our slides earlier. We want to ensure the initial starting position of our stars is random. We want to have each star move at a random speed. And we also want to make sure that initially when we're viewing the scene, each star starts off at various parts of its progression as it's flying through. So we don't want every star to be at 0%. Some stars will have already been flying past us. Some will be halfway between flying past us. Others will be just getting started. We need a healthy, balance of those kind of stars to make sure our effect looks pretty good. And this requires just tweaking some of our initial values. So the first thing I'm going to do in our constructor, in the star, instead of having our counter value be hard-coded, I'm going to do get random int, and it's going to be between the value of 1 and canvas width. And with this change, if I'm going to change that, you can see now that, notice how our stars are moving. Like if I refresh again, different stars are appearing at different times in their life cycle. Some stars disappear and they get reset back into position. And this is starting to look a little bit nicer. Now you can see that it looks kind of like raindrops falling in a windshield where suddenly a star just appears, but we'll get to that, shortly. The next thing I want to do is actually want to change our radius value completely. I want to make sure our radius value is 1 where it starts off small when a star is initially being brought into our view, and it gets larger as time goes on. So I'm going to replace radius with radius max, and I'm going to give it a value of get random int 1 to 10, just like what I had before. So it'll be a maximum value. And similarly, I want to add a speed value. This dot speed equals get random int, and I go from a value of 1 to a value of 5. Okay, now that we created the radius max variable and the speed variable, let's make sure our code is actually using it. So right now I'm going to make sure this dot counter is decremented by this dot speed. This will ensure each star is now moving at its own speed. And then when we are making our radius value, let's see, we are specifying the radius right here as part of our drawing. I want to change that. I don't want it to be the arc version of it. I want it to be specified separately and use radius max is part of its value. So this dot radius equals remap this dot counter 0, and in this case it's going to be canvas width again. It's going to be the maximum, the percentage of it, we're going to be tracking it, but it's going to be from this dot radius max. Hang on, make sure it's right. Yeah, it's going to start off in this case in reverse this dot radius max to 0. So because of how our counter is actually decreasing, we're counting backwards in some ways. So we're going to be starting off at 0 and at 100% it'll be the value of radius max. If we refresh this page here, and now you can see the effect more clearly. You can see that because the radius is now very small when the star starts, we don't get that raindrop effect anymore. Stars are suddenly appearing in the middle, but they're appearing at a size of like 0 pixels or 1 pixel that you can barely see it. And so as they're flying past us and they're resetting, it looks more and more realistic. And the thing that's kind of different though, right? When a star disappears, it kind of retains its same radius value and speed value. Kind of hard to see here, but it does. And so let's go ahead and make sure we randomize that part of it as well. So we go back to the if statement where we check when our counter has gone below 1, which means the star is no longer visible, and just reset the value for radius max. Radius max equals get random int 1 to 10, and this dot speed equals get random int or 1 to 5, just like before. And then if we refresh the page now and a star comes back, it has yet not just its position is random, its radius and speed are potentially random as well. And so now that we've done this, we can kind of see like how our star is pretty much moving at its appropriate speed. Now there's one last thing that we want to do before we wrap this up, and that's something I'm going to leave as an exercise for you to deal with later, and that is the delta time. You know, right now the delta time is this thing where the request animation frame gets called each time our screen redraws. In this case, my screen is a 60 Hz screen, so every second 60 times my draw function is called. But if I were to be on, let's say, a MacBook Pro or an iPhone or some other device where the screen rate is much higher, the request animation frame might be calling 120 times or 240 times a second, which means the animation will be that much faster. So I'll put a link below on reading about delta time and how to adapt this animation to use it. I'm not going to go into great detail because we've already covered a lot of ground, and we covered the hard part, which is really how do we go from just having a blank canvas to having all these small circles, or in this case stars, actually zooming in right at us, appearing and disappearing and reappearing to create the illusion of many, many stars that are currently available. And I did talk about earlier that we have 500 stars right now. Just for kicks, let's make it 2,000. Now, I wouldn't recommend, definitely play around with the number to make sure it works for your audience and we're going for, but let's see what 2,000 stars looks like. And this looks pretty cool, right? There are 2,000 stars now moving across the screen. So you're probably in a very densely part of space. There are a lot of things flying around. Let's make it 5,000. I mean, I'm probably gonna regret this, but let's see what happens. And wow, this looks pretty cool as well. But I'm gonna get it back to 500 just because I do care about all of your CPUs and your graphics cards. And if you're on a low-end device or a mobile device, you wanna make sure it looks pretty appropriate. And so with that, if you have any questions about how this effect works or should work or make modifications to it, or you just want a friendly community where you can talk to others and learn more about web development and other technology topics, check out the forum at forum.krupa.com, where I and others will be very happy to help you out. And before I wrap this up, if you want to keep up to speed on all the things that I keep creating and sharing around all these areas, like, comment, and subscribe on this video, sign up for my newsletter, and follow me at Krupa on most popular social networks, and also write a lot of books on various topics that can help you go deeper into better programming or animation or other related areas. Links to all of that below in the video. And with that, I will see you all next time.